Alright, thanks for joining us for another video. We're doing the friedal acylation. The way this one works is, let's just say we're tasked with, for the friedal acylation, I want you to, before watching this, watch the alkylation video first, please. And then I explain the difference between like the alkylation and the acylation. Really, truly watch that one first. Anyway, assuming you've seen that video already, you would know that the acylation runs in two steps. It always runs in two steps. You got this thing, this with the Cl thing, and the ketone and Cl. This is called an acid halide. We'll learn that later. Anyway, you've got the AlCl3 for step 1, and then step 2 you have H2O, HCO plus, and that's required in order for this acylation to work. That's your product, by the way. And like I was kind of hinting at in the previous video, you're going to want to be able to learn these reactions right off your head, right off the top of your head, as well as the mechs for the mechanisms, for the ones that you're required to know. So without further ado, let's jump right into the video. Okay, so before you can do your pi attack, you got to make your electrophile. How do we do it? You do this. You got lone pairs on the chlorine. Now, this forms a complex. Cl. It basically, all it does, the way I see it, is it just connects all this stuff together. And it's in one big thing. But you need to remember your charges. That's probably the most important thing. The next part is, like I said, the acylation and the alkylation. This thing just kind of falls off on its own. So you get that goodness. This has got a minus on it. You have to remember that. And like I said, it's the same thing as that. These equal each other. Cl AlCl3 is the same as AlCl4. Anyway, you've got this thing that forms. And once again, please, if you haven't seen the alkylation video, watch that, because this will make a whole lot more sense. Basically, we have a carbon there, and we're losing, a bond is being broken. Electrons are going onto this chlorine, therefore rendering this carbon electron deficient. So it's got a positive charge there. This is the way I like to see it, because it makes forming your product really simple. So this is your electrophile. Now watch this. This is where it gets kind of fun. Just you got your benzene, and in order to show this like the easiest way possible, orient this positive charge so that it's really close, so that it's like closest to this double bond. Right now it's not in that position. You have this pentagon in the way. So let's just watch what I mean. It almost looks like a giraffe of some sort. All right. So anyway, you have your giraffe. Now it's time for the pi attack. So you just show it like that. And the way it works is this double bond just goes right on there, and it forms a bond directly to it, which is why I recommend that you just draw it like this. So now it's really easy. You can just basically just show a line between connecting these two, and that's your answer. Boom, just like that. Obviously, we need like our stuff in the middle, like that. We got a hydrogen there, but that's like the big step right there. So just show your res. I like to kind of work from left to right and then go down again, just so when you're reading my answer keys, it makes a little more sense. I'm not a fan of going in circles. I don't do that. It's time for a little deprotonation. Am I right? So another way you can draw this is you can actually just draw it like if you want to, because this is really what the molecule looks like. That's your AlCl4, all this stuff that we talked about up here. Anyway, what I recommend is using the bonds between the Cl and the Al, just one of them. Right there, that goes like that. And you reform your aromaticity. Additionally, you form HCl and AlCl3. That's pretty neat. So now this is where the acylation and the alkylation differ. In the alkylation, you would be done because it's like, hooray, you're done. But in this case, you've got like this oxygen that you got to worry about. Unfortunately, it makes things really annoying. So really what goes on here is there's an interaction between the O and the AlCl3. They actually form a complex, similar to how we had this junk up here, or that complex. We form more of that stuff. So just like that. I feel like Bob Ross talking about a painting. So if you gotta watch those Bob Ross videos of him painting, he's the funniest narrator, I tell you. He is just something else. Anyway, that goes to there. So let me just show it. I'm gonna show them connecting down here so that I can go left to right like I like to. Now this is where you have to consider these lone pairs attacked to make a bond between the Al and the Cl3. So now you have a positive charge on the oxygen and a minus charge on the Al. From here, this is the part of the mechanism that Dr. Montague-Smith did not go over, and this is the part that you really don't even need to know. In fact, he said that if he ever gave you this mech on an exam, then you can show this last step just doing, basically what he said is that the water destroys this complex and gives you your product. So your other products are, HCl and I think it was like AlOH3 or something. Who knows where those come from? All I would do is whatever they were, just memorize them and understand that this is your product. I hope that makes sense. Leave your comments, thumbs up below. Have a great day.